Hello everyone, welcome to Graph Theory series. We are solving question number 1091, shortest path in the binary matrix. So it is a Leetcode medium problem. It is a BFS, breadth first search based graph traversal problem. So it is stated that we have given n cross n binary matrix grid. Return the length of the shortest clear path in the matrix. If there are no path, return -1. So we have to return the clear path. For clear path, we have given a definition. A clear path in a binary matrix is a path from top left means 0, comma 0 to the bottom right means n minus 1, comma n minus 1 such that all the visited cell of the path are 0 means all the cells that we are visiting is 0 and the adjacent cell of the path are 8 directionally connected means we can go to the 8 direction. What the direction will be? This is our 4 direction, this is 6 and this is 8. We can travel in the 8 directions. So we have the length of the clear path is the number of visited cell of the path. So we have to return the clear path length. So let's understand this problem further. Like in this example, we have given we will start from 0, comma 0 node. Then we have to go to the n minus 1, comma n minus 1 node. So we can go to the all direction. So first answer will be we go follow this direction. So how many node we travel? We travel 1 and 2. So for this path the value will be 2. If travel by this path the value will also will be 2. But if we diagonally go to the then our value will be 1. So here you can see the value will be 1. So one thing we have to keep in mind, this node value is also counted. So this is 1. Then we travel to the node value is 2. So we will return for this. The value is 3. The value is 3. Right. In this example, we will clearly understand. We will start from this node. So for the last node, we can go by this direction or we can go by this direction. We can go by this direction or we can go, sorry. One thing we have to mind, we cannot go to the one. So we can go in this direction or so what will be the distance? Distance will be the 1, 2, 3, 4, 5. So its distance will be the 5. Otherwise we can go there, then go there, then we go to the diagonally, then this path. So we travel 1, 2, 3 and 4. If you see this path, so our answer will be 4. So how we are gonna solve this problem? This is a pretty very straightforward problem. As we solve the 0, 1 matrix problem, let's solve this problem in this example. Like we have given this problem. In this problem, I will be creating a queue. I will be creating a queue. In this queue, I will be add three values. One value is row index, means for 0, 1, 2, 0, 1, 2. Row index, column index, and what is the distance? We are starting from this, then we will check this condition. Means first condition our will be if our grid of 0, comma 0 is value equals to 0, means if value is not equals to 0, or will be adding or grid n minus 1 and n minus 1 value is not equals to 0, then we will return -1. Otherwise we will return -1 because if this value is not 0 and this value is not 0, then the clear path cannot be exist. So in this case we will return the value. So this is our the base condition, one of the base condition. Otherwise we create a queue and what we will do, we will insert this index, means we will insert starting index we will, this is row index, column index, and what is current distance? Current distance is 0. Now for each distance, we will be adding, we will travel in a direction. So does it have any zeros in the right direction? Yes, it has in the right direction. So what we will do, we will add this to the queue and mark it visited. We will add this index, means we will add this index 0, 1, and our distance is 1. So this is added. Now, does this have any other? So it does not have any other zeros to go on. Then once like we process this, then we added this, then we will process this. So for this node, how many possibilities we have? We have two possibility. Like we can go to this direction or this direction. So both possibility will be added into our queue. So we can go at index 0, 2 by the distance. Current distance is 1, so we will increase the distance, or we will go to do the distance by the possibility of 0, 0, sorry, by the index of, we will go by the index of 1. We will go first, we will add this into the queue, then we go to this. So we add 1, 2 on with the distance of 2. Now for 0 to 2, does it have any path? So we are not marking it visitor. So does it has any path? Yes, it has a path. Means sorry, it is marked visited, it is marked visited, and it is marked visited. So it does not have any next adjacent path. So we will pop this value. For this, we will add, it has the adjacent value. So we will add 2, 2, and what will be our distance? Distance will be 3. So this is our distance. Then we will process. Since you can check, we have reached our final answer. So we will return distance plus 1. Means what is current distance? Current distance is 3. Then we will add 1. So this is our solution. This is the solution. Let's, what we are doing? Let's again understand our problem. We added this path into the queue because it is our starting position. We insert value 0, means there are distance 0. Then it, we will check it directionally. It has any adjacent neighbor with the values of 0. Yes, it has a neighbor value of 0. We inserted 0, 1 its index, and direction means distance, means we move one distance from this start node. After that, it has processed, then we go to the 0, 1, 1. It has a right side 0 and a diagonal 0. So we will add both values, means it is visited, now it is visited. We will add both value into the RQ. Then 0 to 2. 0 2 does not have any unvisited zeros that is connected to him, connected to this value. Then we will pop this value. Then we go to the 1 to 2. 1 to 2 has a node to 2, and our distance will be added 3. Then we reach to the 233. So its index is n minus 1 and n minus 1. So this is the answer. So we will return d plus 1. So this is our dry run for the code. So in this code you can check. We store, it is a grid n cross n. So we get the grid dot length row value equal to column value. We created a visited array, visited new boolean n cross n, and we created a queue. So for the base condition, if our grid 0 comma 0 and grid n minus 1 comma n minus 1 value does not equals to 0, means we cannot reach to the destination, because if value is 1, we cannot go to the value. So we will return minus 1. Otherwise, we will add the starting position to do our queue and mark it visited. Then we create a 8 dimensional direction array, and after that we will make our basic. We will make our basic DFS approach. Here, one thing you should keep in mind, I am starting from 1 because I have to take care of the this node as well. Means we are starting from this node. Otherwise, if you are starting from 0, then return t plus 1. So we will pop the value from the queue and we will check if it is the last value, means if I equal to n minus 1 and j equal to n minus 1 means it is the last value, then we will return the distance. Otherwise, we will check for its adjacent neighbor 1, adjacent neighbor 0. Then we add the direction and check for the boundary condition, means this is the boundary condition, and grid row and column should be equal to 0 because we cannot go to the 1, and it is not visited. If it is satisfy all the condition, then we will add this value into our queue with the distance d plus 1, means what are the previous distance plus new distance, and we will mark it visited. Otherwise, we will retain minus 1, means if we have not go to the n minus 1 and n minus 1, then we will return minus 1, means our work is done but we did not reach to our destination, so we will return n minus 1. So this is our solution. This is similar to the 0 1 matrix problem. Thank you. It also have a complexity of big O of n cross m. So this is all the problem for today. Thank you.